hello everyone. I'm Linden, and I will be presenting target 5. This problem reads a sequence of positive integers a1, a2, a3, a4, a5 is constructed as follows. A1 equals 1, and for each I such that 2 less than or equal to I less than or equal to 5, AI is equal to AI minus 1 plus 1 with probability 1/2, and AI equals AI minus 1 with probability 1/2. Compute the probability that A1 plus A2 plus A3 plus A4 plus A5 is greater than or equal to 10 and express your answer as a common fraction. And okay, what do we see? We see that we have a sequence of 5 numbers, and what we also see is that these numbers are gonna um, they're gonna either increase by 1 or stay the same each time. So for example, in our worst case scenario, our sequence is gonna be 1, 1, 1, 1, 1. And in our best case scenario, where every integer increases by 1, we get a sequence like 1, 2, 3, 4, 5. And what we want is what's the probability that the sequence has sum at least 10. And you can see that in the first case, the sum is 5. And in the second case, you see that the sum is 15. So why don't we sort of take a look at the behavior of this sequence, because with probability 1/2, if the first term is 1, the second term is either 1 or 2 with probability 1/2. And furthermore, what I'm going to say is that if we do end up increasing from 1 to 2 from the first to the second term, all subsequent terms are going to also increase by 1. So for example, 1, 1, 1, 1, 1, if instead the first number was incremented by 1, we'd get the sequence 1, 2, 2, 2, 2, which has sum 9. That's 4 more than 5. So, in general, by turning the first jump from a plus 0 to a plus 1, so instead of starting from 1, 1, we start 1, 2, that's going to increase the total sum of our terms by 4, because the second, the third, the fourth, and the fifth numbers are all going to increase by 1. For example, if we had the sequence 1, 1, 2, 3, 3, and instead of changing by 0, we change by 1, we get the sequence 1, 2, 3, 4, 4, which has an increase of 4 in the sum. So this first jump, by changing that, is going to add 4 to the sum. And similarly, the second jump, if we were to change, if the second number is a 1 and we change the third number to a 2, then all subsequent terms are going to increase by 1 as well. Similarly, if the second term was a 2 and you increase from 2 to 3, all 3 of these numbers are going to go up by 1. And this third jump is going to be a plus 2, and this fourth jump is going to be a plus 1. And each of these increments happens with probability 1/2. Now, when we ask what is the probability that the sum of these 5 numbers is greater than or equal to 10, what we are doing is we're essentially saying, okay, assume we have a sequence 1, 1, 1, 1, 1. Then with probability 1/2, increase by the sum by 4. And with probability 1/2 independent to the first one, you increase the sum by 3. And with probability 1/2, you increase the sum by 2 and then by 1. And basically what we're asking is what's the probability that we have at least 5 in increases, because all of the ones contribute 5 towards the sum. So we only need 5 more from these 4. Now we can sort of split this into 2 pretty simple cases. Case 1 happens when there's a plus 4. And in this case, all we need is one of these 3 numbers to take effect, because we want a total of at least plus 5, and to do that we just need plus 1 more. So the probability that at least one of these guys occurs, so that is the probability that they're not all plus zeros, and that happens with probability 1 minus 1/2 cubed, because the probability that each of these is a plus 0 is 1/2, and all of them are independent. So in the case that this plus 4 takes effect, the probability that our sum is greater than or equal to 10 is 7/8. Now, in our second case, when this first jump does not take effect, and then what we need is we need these other 3 jumps to contribute at least 5. And this only happens in the case where all 3 of them take effect, so 3, 2, 1, or the plus 3 and the plus 2 take effect. All other cases will have plus 4 or fewer. So the probability that one of these happens is, since each of them happens with probability 1/8, their total probability is 2/8. Now, each of these cases happens with probability 1/2 because the first jump happens with probability 1/2, which means that our total probability that the sum is at least 10 is 1/2 times 7/8 plus 1/2 times 2/8, which gives us a final answer of 9/16. So that was the solution to this problem. That's it from me.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.